Let's talk for a moment about what a model for processing visual information would need to do. The basic task of perception is to take an image like this one and say, that's a bird. So what's going on between the pixels, between the image of the bird and the word bird, is essentially a set of neurons connected to each other in a neural network. So the pixels you can think about as a first layer of neurons, and that's in fact how it works in the eye. That's the neurons in the retina. And those feed forward into one layer after another layer after another layer of neurons, all connected by synapses of different weights. The behavior of this network is characterized by the strengths of all of those synapses. Those characterize the computational properties of this network. And at the end of the day, you have a neuron or a small group of neurons that light up saying bird. Now, I'm going to represent those three things, the input pixels and the synapses in the neural network, and bird, the output, by three variables, x, w, and y. There are maybe a million or so x's, a million pixels in that image. There are billions or trillions of w's, which represent the weights of all of these synapses in the neural network. And there's a very small number of y's, of outputs, that network has. Bird is only 4 letters. So let's pretend that this is just a simple formula, x times w equals y. I'm putting the times in scare quotes because what's really going on there, of course, is a very complicated series of mathematical operations. That's one equation. There are 3 variables. And we all know that if you have one equation, you can solve for one variable by knowing the other 2 things. So the problem of inference, that is figuring out that the picture of the bird is a bird, is this one. It's where y is the unknown and w and x are known. You know the neural network, you know the pixels, and as you can see, that's actually a relatively straightforward problem. You multiply 2 times 3 and you're done. I'll show you an artificial neural network that we've built recently doing exactly that. So this is running in real time on a mobile phone. So what you're looking at is a phone looking at one after another picture of a bird, and actually not only saying, yes, it's a bird, but identifying the species of bird with a network of this sort. So in that picture, the x and the w are known, and the y is the unknown. I'm glossing over the very difficult part, of course, which is how on earth do we figure out the w, the brain that can do such a thing? How would we ever learn such a model? So this process of learning, of solving for w, if we were doing this with the simple equation in which we think about these as numbers, we know exactly how to do that. 6 equals 2 times w, well, we divide by 2, and we're done. The problem is with this operator, right? So division, we've used division because it's the inverse to multiplication, but as I've just said, the multiplication is a bit of a lie here, right? This is a very, very complicated, very nonlinear operation. It has no inverse. So we have to figure out a way to solve the equation without a division operator. And the way to do that is fairly straightforward. You just say, well, let's play a little algebra trick and move the 6 over to the right-hand side of the equation. Now we're still using multiplication. And that 0, let's think about it as an error. In other words, if we've solved for w the right way, then the error will be 0. And if we haven't gotten it quite right, the error will be greater than 0. So now we can just take guesses to minimize the error. And that's the sort of thing that computers are very good at, right? So we can take an initial guess. What if w is 0? Well, then the error is 6. What if w is 1? The error is 4. And then the computer can sort of play Marco Polo and drive down the error close to 0. And as it does that, it's getting successive approximations to w. And typically, it never quite gets there, all right? But after about a dozen steps, we're up to w equals 2.999, which is close enough. And this is the learning process. So remember that what's been going on here is that we've been taking a lot of known x's and known y's and solving for the w in the middle through an iterative process. And this is exactly the same way that we do our own learning. We have many, many images as babies, and we get told this is a bird, this is not a bird. And over time, through iteration, we solve for w, we solve for those neuronal connections.